dishwasher, but it was really hot, so when I went to cool it off, it cracked.
Well, when you put a hot glass under cold water, the outside layers are rapidly cooled while the inside remain the same. This causes tension, which causes the glass to crack. This is called thermal downshock.
That's kind of cool.
This is actually a lot more common than you think. All materials go through temperature stresses. Here, let me show you. Have you ever wondered why athletes warm up before they play their sport? It is because they will perform better if their muscles are loose and flexible, which correlates with their modulus of elasticity. The modulus of elasticity is directly affected by the temperature. Therefore, the higher the temperature, the lower the elasticity. Higher temperatures allow for more flexibility, which is why athletes warm up. For instance, have you ever had trouble opening a jar? If you rinse just the metal lid under the hot water, the metal will expand, making it easier to open. The same is true for structural buildings, except we do not necessarily want the modulus of elasticity to be low. In a steel beam, if it lowers too much, then it could cause failure in the beam or not be capable to carry the load. It is imperative that the temperature stresses are calculated before designing a beam.
That could be really dangerous. How would you know how much stress the beam would be under?
It's easy. I'll show you. Say a W18 by 35 wide flange beam is used as a support beam for a bridge. If a temperature rise of 40 degrees Fahrenheit occurs, how do we determine the deformation that results? The change in length of a structural member is directly proportional to both the temperature change and the original length of the member. Therefore, the total deformation is equal to the coefficient of thermal expansion times the original length of the member times the change in temperature. The coefficient of linear expansion has been determined for all engineering materials. Here we see that the coefficient of thermal expansion for steel is 6.5 times 10 to the negative 6 inches per inch per degree Fahrenheit. So we have 6.5 times 10 to the negative 6 inches per inch per degree Fahrenheit times 40 feet times 12 inches per foot times 40 degrees. We get 1/8 of an inch. Now let's say both ends of the beam were solidly embedded in concrete foundations. How much stress would be induced? Internal stresses develop whenever a design prevents the change in length of a member subjected to temperature variation. The total stress induced is equal to the unit strain times the modulus of elasticity of steel, which is 29,000 kips per square inch. The unit strain is equal to the total deformation divided by the original length of the member, or the coefficient of thermal expansion times the original length of the member times the change in temperature, all divided by the original length of the member. As we know from earlier, the coefficient of thermal expansion for steel is 6.5 times 10 to the negative 6 inches per inch per degree Fahrenheit. Then multiplied by 40 degrees Fahrenheit and 29,000 kips per square inch gives us the total stress of 7,540 pounds per square inch.
Look what else I found. There are lots of different ways to design for the effects of temperature stress. In steel beams that could be exposed to extreme temperatures, they create slot holes for the connections so that the beams can slide around the bolts. This can help prevent excessive internal stress on the connection by letting the beam expand and contract. They even cope the beams when they connect them to the girders, which means they cut a slot in the beams and allow extra space for expansion. That way, if the beam begins to expand, it won't put excess stress on the girder. Bridges are another kind of structure that are frequently affected by extreme temperatures. To prevent extensive stress in the bridge and its piers, builders use roller joints, which allow the bridge to expand freely without pushing on the piers too much. To make sure there isn't too much stress in the bridge itself, expansion joints are placed throughout the concrete so that it can expand and not crack the concrete and cause damage. There really are so many ways to prevent internal stresses due to thermal expansion and contraction.
So pretty much, temperature stress occurs when a material undergoes temperature variation and is unable to expand or contract. This causes internal stresses which make a material fail, and this is why we take this into account when designing.
Come in!
Hey guys, can somebody help me open this jar? It's stuck.
We sure can, Jack.
Well, I'm on the way, the time cold, I wanna be keeping you warm. I got the right temperature for shelter you from the storm. Hold on, girl, I got the right tactics to turn you on. And girl, I wanna be the papa you can be the mom. Oh oh. Because the girl them broke out on the floor. From you don't wanna work this performer. From you don't want a man where can't turn you on. Girl make I see you when them upon ya. Can't stand for the long